Okay. Okay. Oops. I have two instances of this. All right. So we are talking about Gibbs sampling, and yeah, let's take a look. Maybe we can try like a manual example. And we'll say we've got a discrete case. All right, and so maybe you have pouch A, bag B, and bag C, and then I don't know, I'm just making stuff up. Okay, and then within each of these, we've got some marbles, and we'll say in A there's that, and then okay, so anyway, what we have is A, we've got and you can have red, blue, and green. And so A is 30% red. What do I have? 30% blue and 40% green. And blue is 50% red, 40% blue, and 10% green. And C is 10% red, 1, 2, 3, 4, 5, 6, 60% blue, and 30% green. Okay, so this is what we have, and I guess this is conditional distributions on the bags. So the total joint distribution and maybe this isn't the best example because they all have they're all 10 bags each, right? Okay, but in total, we have, what's that? We have 30 marbles, and so here we have 10%, 3 out of 30 are red, 3 out of, we have 10%, 10%, and then 4 out of 30, so this is what, 0.133, and then 0.033, 0.133, 0.167, and then here 0.033, 0.2, and 0.1. Okay, and so the conditional here would be 0.3, 0.433, and 0.167. 0.267. Is that okay? The marginal probabilities. So like red and A is equal to 3 out of 30 marbles, to be 0.1, and then like red and B is equal to 5 out of 30 marbles, so that we have 0.167. That's how I'm getting these numbers. Because if we just look at the joint distribution of everything, this is what we have. Okay, so how would Gibbs sampling work here? So the idea of Gibbs sampling is we want to get samples from this joint distribution, right? So how could we do this? All right. Well, the idea here is, so we already have a conditional distribution based on the bags, okay? And so this is our total joint distribution. And the goal is to get a random sample from the joint distribution. And you know, but we're going to pretend that it's difficult to sample from the joint distribution directly. In reality, it's not. But for the purpose of illustrating this Gibbs sampler example, we're going to pretend that it's difficult to get from the joint distribution exactly. So instead, we're going to calculate the conditional distributions for each variable, right? So we have two variables. What are the two variables that we have? Yeah, what are they? Color and pouch. Okay, and so we need the conditional distributions for each variable, right? Okay, so we need, what is the distribution of color given pouch? Okay, and we already have that. Okay, we have the distribution of color given pouch. This exists. Okay, so if we divide this up right here, we have the distribution of color given pouch, and it's given by each of these things. Basically, the probability of red given A is going to be 0.3. The probability of red given B is 0.5. The probability of red given C is 0.1. And then you could figure this out. Probability of blue given A is 0.3, et cetera, et cetera, et cetera. Okay? and this is represented in this table, the conditional distribution on the bags. All right, what is the other conditional distribution then? Okay. The other conditional distribution will be, what is the distribution of what? What is the distribution of pouch given color, right? So the idea here is, if I take, this is what we have here, would be as if I took these red marbles and these red marbles and this red marble, and I throw them into another pouch. And this is the red pouch. And so we have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9 marbles, and some of them are A. 3 of them are A, 5 of them are B, and then 1 of them are C. 1 of them is C. They're all red. These are all red marbles, but it's as if we stamped an A on each of these marbles and a B on 5 of them and a C on 1 of them, okay? And then, we would create a pouch for the blue, okay? And I would have 3 A's and I forget what did I have? 4 blues, or no, for pouch B, yeah, 4 B's, and then how many C for blue? 6. I'm going to run out of space. I got to make my bucket bigger. Maybe I wrote it wrong. Hang on. 1.63. I can't tell if I colored these in correctly, but anyway, 1, 2, 3, 4, 5, and 6. Okay. So that's what we have in the blue bucket, and then you have one for the green, right? Something, etc., etc., etc. Okay. And then so now the question is, what is the probability of getting A if we have red? And that answer is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. 3 out of 9. Okay. What's the probability of getting A if we're in the blue bucket? And that's going to be 3 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 3 out of 13, and the probability of getting A if we're in the green bucket is something else entirely, right? I have to kind of 4 out of 8, 1/2. Is that okay? And we'd have the probability of blue if we're B if we're in the red bucket, and then the probability of C if we're in the red bucket. So probability of B is going to be 1, 2, 3, 4, 5 out of 9, and probability C is going to be 1 out of 9. And then you kind of fill in the rest here. Okay, so we have the conditional distributions for each variable. Does that kind of make sense? All right. So these are all the blue marbles. And then you have one for all the green marbles, and so on and so forth. Okay, and then so basically you would just sample one variable at a time, and so maybe we just start at an arbitrary location, right? Maybe we'll start at red and A, okay? And then so I'm going to sample. So this will be color and pouch. So I'm going to, so we're going to sample, so this will be at t equals 1, okay? So then what I want is I want to get color at time 2 and pouch at time 2. And then I want to get color at time 3 and pouch at time 3. et cetera, right? So we're going to get color at time 2 is going to come from the distribution of color given pouch A, okay, which is going to be, so given pouch A, our distribution is 0.3, 0.3, 0.4 for red, blue, green. Okay, so how do I draw a random value from this distribution? What do I do? Okay, so we'll start off with U comes from uniform 0, 1. All right, let's go ahead and we'll ask R, give me a random uniform. So I'll say R unif 1. Okay, and it gives me 0.42. Or I'll say 419. Okay, what does this correspond to? How do we turn this into a draw from this categorical distribution? Inverse CDF, okay. So we're going to do inverse CDF. And what does inverse CDF look like here? So if U is between what? If U is between 0 and 0.3, then I would get color would be red, and then the next would be 0.3 is less than U is less than what? 0.6, and that would be blue, and then 0.6 and 1, and this would be green, right? Okay, so based on this, this becomes blue. Is that all right? Okay, and so now that I have blue, then I have P2 is going to come from the distribution of pouch given color blue. Okay. All right, what's the distribution of pouch given color blue? So we can have pouch A, pouch B, and pouch C. Okay. So if I just kind of scroll back, okay, so given that we are, our color is blue, okay, we have 3 out of 13 being A, and then what do we have? Probability of B given blue would be 4 out of 13, and then probability of C given blue is 6 out of 13, right? Okay, and I mean, we can figure that out this way as well. We just condition it on blue, and 0.1 divided by 0.433, 0.133 divided by 0.433, and 0.2 divided by 433. Or, you know, we sum this up, and they add up to 13, and 3 out of 13, 4 out of 13, and 6 out of 13. Okay, so we have 3 out of 13, 4 out of 13, and 6 out of 13, which is 3 out of 13, 4 out of 13, and 6 out of 13. This is P given blue. Okay, so I have 0.231, 0.308, and 0.462. say? 0.231, 0.308. Something's got to give. 0.46, 1-ish. Okay. All right. So then let's draw a random U, RUnif1, and I get 0.0159. Oh, that makes it easy. Okay. So U comes from UNIF01, and I get 0.0159. All right. And so this is going to correspond to what? A, right? So we're going to get pouch A. All right, so our next coordinate, color 2 and pouch 2, is going to be blue A. Okay, and then we would do another iteration, and so now we get, we want color 3. This is going to come from the probability of color given A, which we established was 0.3, 0.3, 0.4. Okay, for red, blue, and green. And then I would draw a random uniform, and I get 0.517. Okay, so RUnif1, 0.517. All right, so this corresponds to blue. All right, and then we'll do pouch given, P3 comes from the probability of pouch given blue, and we established that this was 0.213, 0.231, 308, and 0.461 for A, B, and C. Okay, and then so this time I again draw a random uniform, and I get 0.425, 0 from uniform. And what is it? 0.4255. Okay, and so this will correspond to pouch B, right? Okay, and then so now our new coordinate is going to be blue and pouch B. And then you just continue this. Color 4 would then come from color given pouch B. And that's going to be, I don't know, something different. And you keep iterating this way. So you're alternating between one variable and the other. And for each one, you find the conditional distribution given that thing. Okay? Does that kind of make sense? Right? And so this would be what a Gibbs sampler would look like in kind of a manual process, which we can do for which we can do if you've got a discrete variable. Okay, it's easy. And the idea is if you let this run long enough, okay, you will eventually generate values according to the total joint probability distribution. Okay, so this is our total joint probability distribution where everything sums up to 1.0. But it's really just, we're just varying from conditional distribution. So one, we condition it on the pouch, and then the other is we condition them on the color, and we vary back and forth. All right. Are there questions on this? This is okay? All right. I want to, excuse me, I'm going to post this article called Gibbs Sampling for the Uninitiated, and I think it's pretty great. And anyway, we're going to use our Gibbs sampler to do document classification, okay? And so I'm going to introduce our document. So this is from the article Gibbs Sampling for the uninitiated, okay? And so this will be your weekend homework reading. And what we're going to do is we're going to do document classification via Gibbs sampling. All right, and so the idea is we've got a large body of documents, okay? So we have something called a corpus, okay? Okay, this is our corpus, and this is going to represent all the documents in our data set. Okay, and we want to classify these documents into being of one of two categories. We're gonna just keep this simple, and this could be the idea here was they wanted to do sentiment analysis, being is this document saying something positive, or is this document saying something negative? Okay, but it can easily be expanded. So that's just one of two categories, positive versus negative. Okay, but it can be easily expanded to say, is this document about cars, or is this document about health, or is this document about politics, or whatever it might be. We can expand it easily. Okay, but just for kind of our the simplicity here is we want to classify each document into one of two categories. Okay, so we're going to have basically category 1 versus categories. We'll have category 0 versus category 1. Okay. Okay. And so, so we'll have this will be all documents labeled 0. This will be all documents labeled 1. Okay. And then meanwhile, we'll just have C0, which will be the number of documents. Labeled 0 versus C1, number of documents labeled 1. And, you think of a document as, I don't know, being some kind of article, but, as far as sentiment analysis, the documents themselves could just be like a tweet or something, right? Just a text message, some kind of text. Okay, so each document is really just some kind of text string. Okay. It's just a text string, and we're going to break it up into words, and we're going to treat the document just as a bag of words. Okay, a document is just a text string, we break the document up into single words, and then we treat document as a bag of words. Okay, so this is what we call the bag of words model. Okay. So here, it's just what words appear in the document that's important, not necessarily the order of the words, okay? Which, which means you're losing some information, because if you're in a conversation and somebody says, I think that's a good idea. Yeah, right. It's gonna, we understand that when you say yeah, right, that means I disagree. Okay, but in the bag of words model, it's just gonna see the words yeah. It's gonna see the word right, and these things, and you lose that this is actually somebody saying something negative about the idea. Okay, so some stuff is lost, but but overall, the idea is if the tweet or whatever it is we're looking at has words like terrible and awful and bad, this is probably going to be a negative sentiment, and things that say like fantastic and good and great, these will be positive sentiment things. And it doesn't actually look at kind of the internal structure of the document, right? You could be talking about two things, right? And it could be like, I don't know, so-and-so is great and so-and-so is bad, okay? And then how do you classify that? Is that a positive or negative sentiment? It actually expresses both in the same document. And so, the classification of whether this is positive or negative sentiment, gets tricky. But, anyway, the idea is we're just going to label them either 0 or 1, and we're just looking at the bag of words. So bag of words model, which means the internal order or structure of the words are not considered. Okay, we're effectively only looking at what words appear and how many times they appear. Okay, so I guess we only concern ourselves with, what words appear and how many times they appear. Okay. And the idea is that if we're thinking of how documents might be created, okay, so if we think of a simple model for how these quote documents are created. So again, don't think of documents as like full-fledged articles on your computer, okay? Think of these as like short sentences or statements or tweets, okay? So a simple model for how these sentences or tweets are created, okay? And one is somebody says, I'm going to make a positive tweet or a negative tweet, right? So we do some kind of like a Bernoulli trial. And this will either say, I'm going to go, positive. versus, I'm going to say something negative, okay? And then if they go with a positive document, then what we have is this will modify the probability of their word lexicon, okay? So positive will have a, we'll call this theta 0 versus theta 1. So theta, this represents the probabilities of their, quote, word lexicon. So do you remember that word lexicon that we used in the deciphering thing? Okay, it's kind of like that, except we have a word lexicon with probabilities for positive documents, and we have a word lexicon with probabilities for negative documents, okay? So probabilities of the word lexicon for, I guess, positive documents versus probabilities for negative documents, all right? And probably what we're going to see is words like the maybe has probability 0.05, and this will probably be the same for both documents, right? But in the positive document, words like great maybe has a high probability, 0.04, versus over here on the negative side, using the word great will be very small, 0.0001 or something like that, okay? And words like awful, in the if somebody's going to make a positive document, you know, this will have a low probability versus somebody who's going to say a negative thing. This one might have a high probability, okay? And so we have to imagine, I mean, this is not quite how people write tweets and write stuff, but we're trying to come up with a simple model to explain the different words we see in positive sentiment versus negative sentiment documents, right? And so we want to say, all right, if somebody starts off and says, I want to make a positive sounding tweet, then that means the probabilities of using words like great and terrific and fun and fantastic and happy, like, and rainbows and unicorns, like, we're going to have high probabilities for those words, okay? And then somebody says, oh, I hate the world and I'm going to make a negative document, then words like awful and sucks and stinky and, I don't know, whatever, ugly, those words will show up a lot higher, and you know, words like rainbows and unicorns probably will show up with much lower probability, okay? So we're imagining two separate lexicons, each with probabilities associated with them, right? And then, and so you have this lexicon. So this will have great 0.04, awful this, and, you know, happy, I don't know, like this music makes me so happy, versus, you know, this is going to be something very low or something like that, right? And so there's going to be distinctions between these things, all right? And so now that we have these lexicons, then we can use a multinomial distribution, okay? To produce the document. Okay, and so multinomial distribution is kind of like a binomial distribution. In a binomial distribution, you say, I'm going to flip the coin 100 times, and I want to know how many times it lands on side A versus side B. Or I'm going to do, you know, 100 random draws out of the pouch. How many times do I get a red marble versus a non-red marble, right? And so, you know, you draw 100 times out of the pouch, you get red 30 times and non-red 70 times. That's binomial. Multinomial says, in the pouch, we've got more than 2 categories. You've got red, blue, and green. So if you draw from the pouch 100 times with replacement, you get red 30 times and blue 42 times and green, whatever's left over, 28 times or something like that, okay? And in this case, it's just a pouch, right? With maybe like, I don't know, 1 million balls in there, okay? And then you've got a ball for the word the. And this one, there's 5% of the balls in the pouch have the word the, okay? And then, and maybe 4% of the words in the positive pouch have the word great. And 3% of the balls in the in the positive pouch have the word happy, okay? And so we're gonna just draw like, 20 balls out of this pouch and say, how many times did we see the word the and happy and great and all of this, okay? And that's what will be our bag of words document over here, okay? Over on the negative side, we've got a different distribution for the balls in the pouch. And we're not going to see the word happy and great very often, but we have words like awful and terrible and stinky in there. And, we draw words out of there and we get, a document that looks different, okay? And so this is the model that we have in mind for how our documents are created, okay? Does that kind of make sense for how the documents are made? And so with that model in mind, we can then set up a kind of a Gibbs sampler algorithm as far as if we look at the, because the actual distribution of these pouches, these are unknown to us and we need to infer them from a set of documents that we have, right? So we need to take our data and we need to infer back, these probabilities, okay? The distribution of words in this lexicon and the distribution of words in this lexicon. And we also need to infer back to our the Bernoulli trial that says, the probability for the Bernoulli trial that says, I'm going to decide to make a positive or negative tweet today, okay? And so, so that's where we're going to explore this next week, okay, in our, with the Gibbs sampler, because this allows us to do that. And so, please read through the document this weekend, and, maybe some of it doesn't make sense, and that's okay. I'll try to do my best to explain through it, and this will set up, I think, an interesting application of the Gibbs sampler that's pretty powerful and neat. Okay, have a great weekend. We'll see you guys on Monday.